So another example, we have here a consolidated undrained triaxial test. So a series of consolidated drain tests on a normally consolidated clay indicated a friction angle of 31 degrees. So ibig sabihin, kinandak na drain test. Okay? So ibig sabihin ito yung kanyang angle of internal friction. Then another test is conducted on the same soil, pero ano na siya, undrained na siya. It is on undrained condition, ibig sabihin saturated siya. So on the same sample yields the following results. Confining pressure 200 kilopascal and 180 kilopascal. So dito class, this is a consolidated undrained type of soil. So nangyari dito class ay may given tayong confining pressure and deviator stress. So itong value na to, naka-indicate to dun sa undrained condition. So kung ipa-plot natin yung mga given na confining pressure, that's ito yan, sigma 3, which is 200 kilopascal, and we have a deviator stress of 180 kilopascal. So kung magdodrawing na tayo, wala naman sinabi dito na may cohesion siya, so no cohesion ito. So drawing ulit kayo ng Morse circle, tapos may failure envelope, plot natin yung given. So itong circle na to ay sa undrained condition siya. Okay? It is an undrained condition. Now, yung mga values natin, sigma 1, sigma 3, so nasa undrained condition siya. So kanina may na-mention tayong given na consolidated drain test, yung unang kinandak, at yung nakuha nilang friction angle ay 31 degrees. So yung 31 degrees na yun guys ay hindi yun pwede dito sa nakuha nating failure envelope. Kasi itong angle of internal friction na to ay para to sa undrained condition. So yung 31 degrees na yun ay para yun sa drain condition. So kapag drainain yung soil, okay, so magkakaroon tayo ng panibagong Morse circle, pero since same soil siya, parang magmo-move lang siya to the left. Malilesen lang yung kanyang mga normal stress niya. Okay? O yung mga principal stresses niya. So yung difference nitong dalawa, yun yung ating pore water pressure. So ngayon may isa pa siyang value, si sigma 1 prime. Ito naman sigma 3 prime, para ma-differentiate lang natin ito yung value sa major and minor principal stress para sa drain condition, itong circle na to, para sa drain condition siya. So mas less ang kanyang normal stress. But same lang ang radius niya or yung kanyang maximum shearing stress. So ganun. So nangyari class ay gawa ulit tayo ng failure envelope para naman dito sa drain condition. So yung angle na mako-form nun ay yun na yung ating phi prime para sa drain condition, yung angle of internal friction, which is 31 degrees. Okay? So iba yung sa drain, iba yung sa drain. Compute the undrained friction angle. So undrained friction angle natin ay ito. Okay? Itong angle na to. So yun yung unang required. So mag-focus muna tayo dito sa undrained condition. So paano yan ma-solve? So para wag kayo malito, so dito kasi pinag-isa natin yung figure. So para wag tayo malito, ay hiwalay muna natin yung drain condition. So gawa ulit tayo ng drawing. So alisin muna natin yung drain condition. tira na muna natin to undrained. So, erase natin to. Yan. Okay. So, para sa drain condition, ito lang yung ating drawing and drain condition. Okay, so ito yung required angular internal friction sa drain condition. So, given na yung deviator stress, makukuha agad natin yung radius nitong ating Mohr circuit. So, yung radius natin, ito tangent niya, punta dyan. So, ang radius nito ay kalahati nitong deviator stress na 180 kilopascal. So, the radius is 90 kilopascal. So, 180 divided 2. So, this is right triangle. So, galing doon, dito sa right triangle na to na ma-form natin, dito natin masosolve yung angular internal friction. Since itong distance na to, kapag inad natin, is just the sum of 200 kilopascal or yung confining pressure and yung radius niya. Kasi ito radius din to from this point to the center. So that's 90 kilopascal. So add natin 290 kilopascal tong distance na to. So again, mag-focus tayo dun nga sa right triangle na na-form which is 290 kilopascal and yung angle of internal friction and itong radius. So sine function, sine phi equals to r over 290 kilopascal. So phi is equals to arc sine of r is 90 over 290. So masasolve na natin siya. Ating phi ay arc sine of 90 over 290. So, ating sagot para sa undrained angle of internal friction is 18.08 degrees. Okay, that's the answer. Para sa letter A. For letter B, itong sunod na tanong, compute the pore pressure at the time of failure in the consolidated undrained test. So, ano na ngayon yung ating pore pressure? So, sige, i-copy ko ulit ang figure. Okay, so dito, para sa question number 2. So, hanapin daw natin yung pore pressure. Pore water pressure. So, for the pore water pressure, so yun nga, yung U. Okay? So, paano natin mahanap yung U? So, sa drain condition, same circle din siya. Okay? Same circle ang magagawa natin. Okay? So, gawin natin, kunin natin tong radius ulit nito, which is, alam naman na natin na 90 to para sa drain condition. So, kung titingnan natin, may mapo-form tayong right triangle again. Itong right triangle na to para sa drain condition. Okay? So, kasi dyan, kunin natin tong horizontal distance na to from the origin hanggang dun sa center nitong drain condition. So, bakit natin yan nahanapin? Kasi, yun ang itong way natin para makuha itong distance nito o yung ating pore pressure. Okay? So, ito yung 3', ito yung sigma 3', ito yung sigma 3. So, yung difference nila, yun yung pore pressure, which is same lang naman siya dito. Okay? So, hanapin muna natin tong distance nito. So, paano yun mahanap? May given tayo angle of internal friction on drain condition. So, i-redraw ko lang. This is phi prime, 31 degrees. Let's say this is distance Z. Okay, distance Z. Tapos ito yung radius which is 90 kilopascal. So, that's the radius. So, gamit yan. Sinove ko yung Z, distance Z. Makuha natin is sine, right triangle. 31 degrees equals to R over Z, or Z equals to R over sine 31. So Z is equals to 90 kilopascal over sine 31. So Z is equals to 174.744 kilopascal. So galing dyan, makukuha natin itong distance na to. Itong distance na to galing itong distance na to. Okay. So, para makuha yan, sa di ba class, meron tayong given na 200 kilopascal po yung ating confining pressure sa undrained condition. So, gagawin natin itong 200 kilopascal na to, which is galing dito. Okay. So, di ba galing siya dyan? Kapag sinubtract natin itong pore pressure, di ba ito na yun yung sigma 3 prime. Or simply, that's 200 minus U. Tama? Okay. So, gagawa lang tayo ng equation class, equating this distance right here. Itong green, 200 minus U plus yung radius nitong drain condition. I-equate natin dun sa kinompute kanina natin na Z. So, mangyayari class. So, mangyayari ay ito na ang solution natin para dyan. That is 200 minus U plus yung radius ng ating semicircle is just equals dito sa distance Z natin na kinompute natin kanina. So na, may Z tayong unknown U, meron ding radius. So, ayusin lang natin yung equation. We have 200 kilopascal plus yung radius natin, let's say minus Z, transpose ko na, at yung U naman, pinilipat ko dun sa kabit. Or vice versa, pagkitarin natin, parang ganito din siya. U equals to 200 kilopascal plus R minus Z. So, U equals to 200 plus radius na 90 minus Z na 174.744 kilopascal. So, U is equals to 100 plus 90 minus 174.744. 115.256. So, yan ang ating for water pressure. Okay? So, yan. Ito na yung question, letter B. Okay. For the next question, compute the shearing stress at failure plane for the consolidated drain test. So, at drain condition, ano naman kaya yung shear at failure? So, tinatanong dito class yung shear at failure. So, sige, kopyahin ulit natin itong figure. So, pwede naman natin class ihiwalay yung drawing para sa drain condition. So, gawin natin, alisin lang natin itong undrained condition. So, para tayo malito. Alisin natin yan. Okay? So, wala na. Ito itong mga given na iba. Okay, so yun. So, given naman yung ating angle of internal friction and drain condition. So, syempre, yung kanyang deviator stress, same pa din. Yung diameter. So, yun lang. So, i-drawing ulit natin yung radius. Ibigit na natin. So, yan. Yung radius. So, it's 90 kilopascal. So, yun. Tinatanong dito class yung yung shearing stress at failure plane. So, yung failure plane niya natin ay nandito. Dito sa point na to. So, yung shearing stress niya, kunin lang yung vertical distance niya. Okay? So, itong vertical distance na yan, yan yung ating shear at failure plane. So, para makuha yan, again, kunin natin tong angle na to. Say beta, angle beta. So, makukuha yung angle na yan when we take into consider this triangle. Here, this right triangle. So, if this is a right triangle, makukuha natin yung beta. Beta which is equals to 180 degrees minus yung phi prime minus 90 degrees. So, ito yung sum ng yung sum ng lahat ng interior angles ng right triangle equals to 180 degrees. So, 180 degrees minus 31 degrees minus 90 degrees. So, ang beta natin ay 59. So, that's 59 degrees. So, pwede na natin ma-solve tong tau f. Using sine function, sine beta. Ito naman na right triangle na to. Okay. Which is tau f over r. Tau f equals to r sine beta. So, r is 90 kilopascal sine beta, which is 59. Okay. So, shear at failure is 90 sine 59. So, 77.145. 145 kilo Pascal. So, yun yung sagot class dito sa third question natin. Okay. Another example, an unconsolidated and drained test was conducted on saturated clay. The cell pressure was 200 kilopascal and the failure occurred under the deviatoric stress or deviator stress of 220 kilopascal. So, ang cell pressure class, siya yung confining pressure din. That is also confining pressure. So, may iba-iba lang na term na mga ginagamit. Mga parehas yan. Kaya yung sigma 3. So, it has 200 kilopascal. Yung deviator stress natin, 220 kilopascal. Determine the angle of shearing resistance. Determine the maximum principal stress failure and determine the undrained shear strength. So, dito class sa unconsolidated undrained test. So, mag-drawing ulit tayo ng semicircle. So, given 200 confining pressure, okay, 200 kilopascal, ito yung sigma 3. Yan, distance na yan, galing sa origin. And deviator stress of 220 kilopascal. Okay, ito yung sigma 1. So, yan. Ang angle of shearing resistance or angle of friction class sa unconfined undrained o UU ay hindi ko kasi class na present dun sa PowerPoint. May similarity sa UC which is ang kanyang failure envelope ay horizontal. Okay, so yan, horizontal line na yan. Okay, horizontal line. So, hindi kasi. Okay, so yan, horizontal line. So, ibig sabihin kung ganyan yung ating failure envelope sa UU, okay, exclusive lang to sa UU, unconfined, undrained. So, this is your failure envelope. So, ibig sabihin, ang angle of internal friction natin, which is yung reference natin itong failure envelope, from the horizontal, ibig sabihin, ang ating angle of internal friction ay 0. So, yan na yung sagot dyan sa unang tanong. Angle of shearing resistance, angle of internal friction. Next, maximum principal stress at failure. So, ang ating principal stress at failure, so point of failure natin ay nandito. But yung tanong ay maximum principal stress o yung maximum normal stress. So, ang maximum normal stress natin ay ang location niyan ay nandito. So, ang ating maximum principal stress ay just take the sum of 200 and 220. So, for letter B, ang sagot dyan ay kapag inag mo yung dalawa. That's 420 kilopascal. So, this is the answer for letter B. Okay, at lang yung dalawa. For letter C, the undrained shear strength. Okay, undrained shear strength nito. So, yung undrained shear strength natin, syempre dito yung ating maximum shear. So, yun na din ang ating undrained shear strength natin. Kasi yung tau max natin. So, yung tau max is just yung radius no semicircle. So, kung meron tayong deviator stress na 220 kilopascal, so divide lang natin siya sa 2. So, that's 110 kilopascal. So, yun na. Yun na yung sagot dito. So, madali lang kapag unconfined, undrained test. So, simple lang ang drawing. So, next. So, here's another example for unconfined, unconsolidated undrained triaxial test. So, meron tayong given na clay soil. So, at failure daw, the major and minor principal stresses are 140 and 50 kilopascal. So again, drawing lang tayo ng semicircle. Meron tayong 140 and 50 kilopascal. Okay? 140 kilopascal para sa major. Ito naman yung minor principal stress. That's 50 kilopascal. So required, hanapin yung cohesion of the soil. So, ang cohesion ng soil natin, since UU siya, under tayo sa UU, so horizontal line ang ating failure envelope. So, kung saan niya in-intersect yung y-axis natin, kung saan doon yung values ng shear stress. So, yung value ng shear stress niya doon ay yung ating cohesion. So, para mahanap tong cohesion na to? So, una, hanapin muna natin yung difference nitong major and minor principal stress. So, kapag sinubtract natin to 140 and 50, makukuha natin yung diameter nitong semicircle, which is 90 kilopascal. So, kung meron na tayong diameter, pwede na natin makuha yung kanyang radius. So, kalahati ng 90 ulit, that's 45 kilopascal, which is just equals to the cohesion. Okay? So, ito na yung sagot sa first question. Second question, if the soil were subjected to an unconfined compression test, what actual stress would result of failure? So, point of failure natin, yung tinatanong, dyan dito. That's the point of failure plane. So, nahanap daw yung ating axial stress dun sa point na yun. So, kung hanapin yung axial stress, so ito lang naman yan, yung horizontal distance from the origin. Punta dun sa point na yun. So, makukuha lang naman ito kapag inad natin yung minor principal stress, 50, itong distance na to, plus yung radius. Okay? Plus radius na 45 kilopascal. So, that's 95 kilopascal. Yan na yung sagot natin para sa sigma F or the axial stress at point of failure. That's the answer for letter B. For the third question, what is the magnitude of the shearing stress at a depth of 3 meters below the ground surface? Unit weight of the soil is 15 kilonewtons per cubic meter. So, balikan lang natin class yung general equation para sa shearing stress. That's equals to C plus sigma tan phi. So, phi natin dito ay 0. So, tangent of 0 is 0. Cancel out yan. So, ibig sabihin, yung pinapahanap na shear stress is just equals to C. That's 45 kilopascal. So, yun na yung sagot class. So, that ends our lecture class in triaxial test. So, ang triaxial test, isa to sa mga paborito na lumalabas na problem sa board exam. I think Every board exam laging lumalabas ang hindi nawawala ang triaxial test. So, again, be familiarized kung yung proseso ng pagsosolve, tamang pag-drawing, paglagay ng given, at yung mga terminologies used in solving problems in triaxial test. So, that's another lecture. Thank you for watching. God bless.